So this video is going to be about symbolic and isotope notation. And so this first kind of one that you see is our symbolic notation, and that is because it has, well, the element symbol in it. And so what you're going to want to pay attention to is the fact that the top number is our mass number, which, just as a refresher, is our protons plus our neutrons. And then this bottom number is our atomic number, which is simply our protons. And so you might also see located here, in which case there's nothing here. That would be where our charge is. If nothing's there, that means it has a charge of 0 or that the atom is neutral. And so if you see this and it's asking you to calculate the number of protons, neutrons, and electrons, we know our protons because our atomic number. Our neutrons would be our mass minus our atomic number, so 1 minus 1 is 0. And then our electrons, because it is neutral, and actually I'm going to show our calculation here. Our neutrons would be 1 minus 1 equals 0. And then our electrons would be our charge, or our protons, minus our charge, which is 0, which gives us 1 electron. And I'm going to put our symbols there with it. And so for this one, you can see that its mass number has a mass number of 2, which makes all 3 of these isotopes. Okay, they are all hydrogen, but they have a different mass number, which means they have a different number of neutrons, which we'll see in our calculation. It has 1 proton because it's atomic number. The neutrons are 2 minus 1 equals 1 neutron. And then our electrons are 1 minus 0, which is the charge because it's neutral, equals 1 electron. And for this third hydrogen at the end, it has 1 proton because its atomic number is 1, which, again, our atomic numbers are always this bottom number here. All 3 of them are 1, which is why all 3 are hydrogen. And then the neutrons would be 3 minus 1, which gives us 2 neutrons. And then it's neutral, so 1 minus 0 gives us 1 electron. And so all 3 are isotopes because they all have a different number of neutrons, but they have the same number of protons. So they're all hydrogen, they have a different number of neutrons, and therefore a different mass number at the top. And so if we look at the next set of symbols, in this case about oxygen, we can again calculate our protons, neutrons, and electrons. So our protons, for all of them, are 8 protons because they all have an atomic number of 8 here at the bottom. And for neutrons, it's our mass minus the atomic number. So 16 minus 8 gives us 8 neutrons. For this one, it's 16 minus 8 gives us 8 neutrons. And for this one here, it would be 18 minus 8 gives us it gives us 10 neutrons. And for our electrons, it's our protons minus the charge. So for our electrons, it would be 8 minus 0 gives us 8 electrons. And here it would be 8 minus a negative 2, which when you subtract a negative, it becomes positive, so that gives us 10 electrons. And then for this oxygen, it's 8 minus 0, which gives us 8 electrons. And so we would say that this one and this one are considered isotopes of each other. They're the same except for their neutrons, whereas this one and this one are ions. And in fact, this middle one, because it has a negative charge, that tells us it is an anion because it has a different number of electrons. And so this is kind of some symbolic notation, and we will do another example. In this case, our example is magnesium. And so for our protons, we have 12 protons for all of them because the atomic number is 12, and they are all magnesium, so they have to have the same number of protons. And then for our neutrons, it's the mass minus the atomic number. So remember, protons are equal to your atomic number. Your neutrons are equal to the mass minus the atomic number. And your electrons are equal to your protons, or your atomic number, minus the charge. And so for our neutrons, it would be 24 minus 12 gives us 12 neutrons. And the electrons, it has a charge of 0 since there's nothing there, so 12 minus 0 equals 12 electrons. And then for this center one, we have 26 minus 12, which gives us 14 neutrons. And it also has a charge of positive 2, so that means 12 minus 2 gives us 10 electrons. And then the far right one is 26 minus 12, which gives us 14 neutrons. And then we have 12 minus 0 gives us 12 electrons. And so, again, this is just practice for seeing this kind of symbolic notation. This type of notation is called isotope notation because the only thing you can tell about it is the mass number and the element. So we have our element name that's written with a dash and the mass number. And so what we can tell is, unless otherwise stated, you assume that they are all neutral, because this is just meant to tell you the mass number and how many neutrons there are. So because all of these are carbon, that means that they all have 6 protons. So we have 6 protons for all of them. And then because the 12, 13, and 14 are all of the mass numbers, we can use that to calculate our neutrons. So our neutrons would be 12 minus 6 equals 6 neutrons. 13 minus 6 gives us 7 neutrons. And 14 minus 6 gives us 8 neutrons. And because we're assuming that they're all neutral, that means our electrons are equal to our protons, so we must have 6 electrons for all of them. And for hydrogen, we could say that we all have 1 proton because hydrogen on the periodic table is number 1. And then our neutrons would be 1 minus 1, which equals 0 neutrons. And here, 2 minus 1 gives us 1 neutron. And here, 3 minus 1 gives us 2 neutrons. And again, neutral means that your protons are equal to your electrons. So I have 1 electron for all of these. And so that should have been just a really quick review of symbolic and isotope notation.